welcome guys. So here comes our final question in GRE Physics GRE. Okay, and 100 is the somehow difficult question. And basically, you have some absorption spectrum of 14.4 keV gamma transition, and this is only you have. And he has here about the time. Okay, and so basically, to get this one, you need to know two things. The first thing is that you need to find. So there's a formula close to the uncertainty principle. The one famous is this one, or close to H bar. Another is famous one. So the problem is we need to find, we need delta t, so we need delta e. So how do we find a delta e? So there's no delta e information here. We only have velocity information. But remember that in the Doppler effect of light, as I mentioned, since you have the velocity changes, velocity delta v, so delta v will have delta lambda, and the delta lambda will imply the delta energy, and delta energy can solve delta t. Okay, so this is the whole process. Okay, so let me start. So basically, you need to see the delta v. Okay, so let me see delta v. It should be probably 1 to. This is 1 millisecond s. So suppose I just that. So I can assume that v is just because it's too small. So lambda prime is close to lambda plus 1 plus beta square. So delta lambda is just close to 2 lambda delta beta, 2 lambda delta beta. Oh no, sorry, I forgot. So this is, maybe we can do slowly. So this tells you that delta lambda is 2 beta lambda, because delta lambda is lambda prime minus lambda. So you have this. Okay. Then we need to find delta E. Okay, so delta E is just delta partial E, partial lambda, delta lambda, which is E is just HF, so it's HC over lambda. So this can be solved very quickly by this one. But since we only care about the magnitude, so this minus sign actually does not matter. Okay, so this tells you that the magnitude delta E over delta over E, basically this is E over lambda, is delta lambda over lambda. Delta lambda over lambda is 2 beta. Okay, so now you know the delta E is E times 2 beta. Okay, and the final is that delta T times delta E is 2 H bar. So delta T is H bar over 2 beta E. So it's 6.6 negative 24, and plug all the information you have. So 2 beta is what? 2 beta is this is E. This is you need to times the. So this is E. So this is E. Which from kV we change into the joule, and this 2 is this 2, and the beta is 2 over 3 times 10 to the negative minus 11, because you know that V is close to 1 millimeters. So basically this is and the C is 3 times 10 to the 8. So basically your V over 6 is here. So compute this, you get delta T is close to 10 to the negative second. So complicated. So the answer is C, because 1 nanosecond is 10 to the negative 9. So what we have is the answer C. That's it.